Good morning, students. Today we will be learning the chapter 3 based on elements, compounds and mixtures. So here are the three pictures. So you can see pure honey, pure foods and pure milk. So what does the word pure means? So we shall see what is the meaning of the word pure. So here, what does the word pure means? It means that pure means all the constituent particles of that substances are the same in their chemical nature. So here we see this is a gold and the chemical nature. See, the gold is bounded with the similar kinds of chemical substance. So here we see about this matter. Everything around us is made up of matter. So matter is anything that occupies space and has mass. So we know that matter which can occupy space and has mass. Now here we see matter. Matter is divided into two parts, that is pure substances and impure substances, which is known as the mixtures. So here we see pure substances. Here pure substances means a homogeneous material which contains particles, atoms or molecules of only one kind and has a definite set of properties. So pure substances are of two types. These are elements and compounds. So here we see elements are pure substances as all the atoms of a specific element are same. Now we see here pure substance, and we see it's homogeneous mixture. This homogeneous mixture means those mixture when you combine together they can form only one particular compound. So that is known as homogeneous mixture, like water and a sugar. When you mix a water and a sugar, then it becomes a one compound, one solution. Okay, so here we see elements are pure substance as all the atoms of a specific elements are same. So elements is also a pure substance which has the same elements, which has the specific chemical properties, chemical natures are same. Now here we see compounds. Compounds are pure substances as all the molecules of a specific compound are same. So even this compounds is also a pure substances in which all the molecules of these compounds are same. Here we see on top you will see pure substance. You find there is one inside a bracket you find atoms or molecules. These atoms or molecules, atoms, we know what is atom. Atom is a smallest particle of an element, and molecules means molecules are the smallest particle of a compound. Now we see examples of these pure substances. Example of pure substances are copper, aluminium, gold. And now we see pure substances. We shall see pure substances in different forms. Chemical form, in chemical elements like tin, sulfur, diamond, compounds, sugar, water and baking soda, crystals, salt, protein crystals, copper sulfate crystals. So can you study this part? Now we see note. All homogeneous mixtures are not pure substances. Like for example, homogeneous means same one compound which when you combine it forms one compound. So like for example, sugar solution in water is homogeneous, but it consists of two different substances, that is sugar and water. So here sugar and water, when you mix sugar and water it forms one particular compound, so it becomes homogeneous, means you mix and you cannot separate it anymore. So that particular solutions or compounds is known as a homogeneous. Next, characteristic of a pure substance. So characteristic of a pure substance, it is homogeneous in nature. It has definite set of properties. Like example, a molecule of water consists of two atoms of hydrogen and one atom of oxygen. Water formula H2O. And it has specific melting and boiling points and characteristic color, smell and taste. And it has also fixed physical and chemical properties. Now we shall go to the next. We shall see the elements. As we have already learned before, an element is a pure substance in which you cannot break into two or more simpler substances by any physical or chemical means. And this element consists of only one kind of atoms. And remember, it's very important, there are 118 elements so far. So among these 118 elements, 82 are normal and 36 are radioactive. Now elements are subdivided into 4 parts: metals, non-metals, metalloids, and noble gases, which are also known as inert gases. Now we shall see the properties of metals. Metals are good conductors of heat and electricity. Metals are malleable. So malleable means which you can hammer or make into thin sheets, okay? And metals are ductile, and the meaning of ductile means which you can be made into chains or thin wires. So metals have high tensile strength. Okay, metals have high tensile strength. Tensile strength means force which required to pull a substance. So metals have luster. Luster means shining. Now see this figure. You can see this figure. This is an example of metals. And now we will study about these non-metals. We see these non-metals like carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. Non-metals are very poor conductors of heat and electricity, and non-metals tend to be brittle. Many non-metals are gases at room temperature, okay? And a carbon, graphite in pencil lead to a great surface. Now properties of metalloids. Metalloids, as we know, what is the meaning of metalloids, as we have studied in the classroom. So they have properties of both metals and non-metals, okay? Metalloids are more brittle than metals, less brittle than most non-metallic solids. So these metalloids you have to study nicely, and these metalloids are semiconductors of electricity. And now noble gases: helium, neon, argon, krypton, xenon, radon. So these are the noble gases. Noble gases have 8 valence electrons except helium, which has only 2. Noble gases are only found pure in nature. They are chemically unreactive. So very, very important. They are colorless, odorless, and unreactive. They were among the last of the natural elements to be discovered. So it is important. Now we shall see the compound. A pure substance which is made up of 2 or more elements combined chemically in a fixed ratio by weight, and it can be broken down into elements by chemical methods only. It is known as a compound. So this compound's definition, which is made of 2 or more elements. And this characteristic of compound, let's see this characteristic of a compound. Characteristic of compound: it is a homogeneous molecules, and it has fixed composition by weight. It has a fixed like their composition is fixed. Like for example, in water, hydrogen and oxygen are combined together in a fixed ratio 1:8 by mass. It is very important. You should know the hydrogen and oxygen combined in a fixed ratio 1/8 in mass. And a compound is formed by its constituent elements by chemical reaction, not physical reaction, chemical. So the constituent elements compound can be made. So characteristics of a compound. Now a compound can be broken into its component elements by chemical methods only, as we have already said before. The properties of a compounds are different from those of constituent elements. They have different compounds, and they have different forms of constituent elements. And like for example, in water, hydrogen and oxygen, you find hydrogen and oxygen. So hydrogen is inflammable, whereas oxygen supports combustion, but water extinguishes fire. So this formation of a compound involves energy changes, and a compound has its own characteristic melting and boiling point. So it's important. Now we see this mixture. We shall kindly see this figure. A material obtained by mechanically mixing 2 or more substances in any proportion, in any quantity. So they are known as a mixture. So this is very important to know the examples. You can see the picture. Now based on the uniformity of the constituents of mixtures, we see there is homogeneous mixture and heterogeneous mixture. Very, very important, okay? So kindly try to study homogeneous mixture. So in this kind of mixture, you can distinguish the components, like you can separate it, okay? Like for example, tea and sugar, milk, coffee, all those are homogeneous mixture, in which when it is mixed, orange juice and all, So when it is mixed, you can separate the orange as well as the water. You can't separate. Like now, see, heterogeneous mixture means you can distinguish, you can identify. Okay, you can identify. Like for example, salad, you mix like carrot and onion, you mix it, but you can distinguish, you can separate it. Like you can identify which is carrot, which is onion, right? So these are the heterogeneous mixture. They are also a mixture, but you can identify. Now we shall see true solution, suspension, and colloids. Now homogeneous, heterogeneous, and heterogeneous again. Now homogeneous is a true solution, is a homogeneous, like a homogeneous mixture of two or more components. The dissolving agent is the solvent and the substance which is dissolved is the solute. Heterogeneous, colloids, particles intermediate in size between those found in solutions and suspensions. They remain evenly distributed without setting out. Heterogeneous, particles are larger in size than those found in solutions. Components can be evenly distributed but will settle out over time. Now we see where under these true solutions you will see one, that is the solution agent, solvent, and the solute. Solvent means like the water in which the solute can dissolve. Solute is like, for example, like sugar, in which you can put in a solvent and it gets dissolved. So like for example, difference I will explain you with a different with an example of sugar and water. Solvent means like water, and solute is like sugar. So when you mix this solute, that is sugar, in a solvent, that is water, then it becomes a solution. Okay, so that is known as a true solutions. So this colloids, this intermediate in size between those found in solutions and suspensions. They remain evenly distributed without setting out. So these colloids are they are particles which is intermediate particles and in size between those solutions and suspensions. Even suspensions same. So kindly study, dear students. So if you have any doubts,